Good afternoon, everyone. Hi. My name is Vakhtang Satria, and I'm a voice TSP at Microsoft, based in Melbourne. I've got my good friend and colleague, Victor Dochetkov, voice architect, and we're going to be presenting Lync Enterprise Network. No, we're going to speak very slow. Can you please turn the volume a little bit up? Excellent, thank you. We understand that this session is probably the only session between you guys and the party, so we will try to make it very interesting for you guys, and hopefully it will be very, very interactive, so ask us a lot of questions. And as a matter of fact, if you've been on the previous session, you probably have seen we've got a lot of giveaways from our good partners. Good question. Ask a good question, that's a deal, you get a prize. And okay, come to showcase, we have a special prize for that question. And if you have been on my presentations, I usually have a special arrangement if you ask a very, very good question that we probably can't even answer or put us into the much, much bigger confusion, definitely related to our technology. We double the price. It's been happening last year, for example, and it's been happening during a year. So please interact with us, and let's make it as interactive as possible. So just probably to get a feeling of what sort of the knowledge we have in the room, can you please raise a hand if you are coming from the data world, which is telcos, ISP routing and switching, BGP, OSPF, spanning 3 worlds? Okay. If you're coming from the voice world, pure voice world, which is a bit of voice over IP, but mostly analogs, extensions, call parks. Okay, music on hold. All right, so the rest are probably the rest are IP people, which involved a lot of servers, I would assume. Okay, it gives us. And the last probably question: if please raise your hand if you're running Lync in a production with all modalities, which is enterprise voice, IMAN presence, and conferencing, up to 2,000 users. Over 2,000? All right. Great. So the rest are probably for Microsoft salespeople. That's an opportunity. All right. What we would like to cover today, that when you bring voice and voice over IP Lync itself into the enterprise network, we definitely know that it's going to make an impact to your network. And in order to basically manage that net impact and understand actually what it is changing with your network, we thought it's a good way actually go back to the basics and understand what was the voice evolution, what actually makes voice to be success within your network, and what sort of stuff you really need to have a look. And as I usually say, understanding those basic, you probably will start understanding what you have to make, actually, why we have to make certain things in a different ways to make voice working in your enterprise network environment. So we'll talk about network considerations, we'll talk about some bandwidth, call admission control, quality of service, VLANs, all this sort of stuff. But before that, we want to go back to a little bit of basics and probably to set the scene. So I'll pass it to Victor. Here we go.
Sorry, not my fault.
You need a prize.
Yeah. Sorry, as Vakhtang said, that Lync definitely will have some impact on the network. But I would actually rephrase it and say the network will definitely have an impact of your Lync experience. And I have a very short story from my personal experience. It was in 2008 in Russia. At that time, I worked for a system integrator. And our video conferencing department were about to sign a very good contract with semi-government customer. It was for about $4 million. So we met all the requirements of the customer. We were very confident that we are going to win that contract. And the customer asked for a proof of concept within their own environment. It was the main reason for that proof of concept, or even demo, was to check the potential end user adoption level. So they wanted to see if the top executives will be able to use that video conferencing solution. We're very, very confident that we will be successful because that solution had a very user-friendly interface. It was completely localized, so it had Russian language everywhere in end-user interface. So I actually participated in this project only to enable voice integration to existing IPPBX. But we were very confident that we were successful. We sent, on our expenses, we actually sent a number of video endpoints to the regions, and we installed all the necessary equipment in the main location because we were sure that the customer is going to buy all that stuff anyway. So the customer actually provided dedicated WAN links for the demo. So video conferencing engineer decided not to spend any time on configuring quality of service or call admission control because there were no any other traffic on that WAN links. So they were completely dedicated for us. And at the day of the demo, there were a very top executives people in main location and branch managers in regions. So we started a demo from the main location, but I think we were too successful on the main goal. So the solution was very user-friendly. So people in regions, they felt themselves a little bit isolated, and they started to call each other. Even worse, they started to make an additional video conferences. So as you can imagine, that WAN links were very quickly overloaded. And we had a very poor voice and video quality in main location. So the very, very top executive was very disappointed with the quality. And we didn't manage to explain him because he didn't actually wanted to hear or to listen any explanation. So we lost that deal. So as you can see, you can have a winning solution, but not providing the appropriate service on a WAN, or on LAN, on network, basically. You can actually lose and compromise the solution, compromise yourself. Be careful. So this is why we're going to cover the following topics. We will talk about the quality of service and some technologies like DSCP to mark packets. We will talk about port ranges, etc. We will very deeply touch call admission control. We will also talk about the resiliency and partners, as well as about monitoring, because monitoring is critical to resolve any particular issue and also to predict any bottlenecks, etc. You should be proactive to deliver as better voice quality as possible. So before we start, let's just review the evolution of voice transport. In all the days when we had a TDM network, any particular call will use the same path, and that path will remain until the call is ended. Moreover, in 99%, the condition of that path will remain the same during the call. Even more, you as a telco administrator can configure exact way for your voice path. But now, with voice over IP, we have source, we have destination, and network in between. And as you know, the codec works, he's actually analyze the voice and produce a number of packets. That packets can travel different ways on the way from the source to destination. And some of them can be delayed, some of them can be lost. And this is why we need all the technology we are going to talk about to be sure that we can provide a good voice quality similar to what user used to have within TDM world. Then let's define what is a voice quality is about. First of all, is about how your system is reliable. Users want to be able to make a call anytime, so they want to be sure that when they pick up the handset, there is a dial tone. They want to be sure that the call will remain stable until they put the headset back to the hook. They don't want the call to be interrupted in the middle of the call. Then the second criteria is audio quality. So they want to be able to understand what the remote site is telling them without any challenges and difficulties. And who is matter? Of course, end users. They want to have a good experience. And admins. They want to have a good quality of life, admin life. So they want to be able to monitor and proactively see any potential issues. They want to be able to easily resolve and troubleshoot any reported issues. How to measure, how we can measure voice quality? There is two options. There is two main options. First of all, mean opinion score, which is quite subjective because in this score, a personal opinion is used to measure the voice quality. And there are 5 ratings for mean opinion score, starting from the 1, which is unsatisfactory. In this case, you will probably hear just call me from another line. That's it. And up to the excellent rating, which is similar to as you speaking a person next to you. But in most cases, we're looking for a good quality. Another way to measure the voice quality is perceptual evaluation of speech quality, which is more objective because it's using an algorithm to analyze the original input and then to analyze the transmitted voice and then compare two results. It will give you the same result every time you run the test. But most can give you different results based on the personal mood. So now, what is the constituent of a good voice quality? The most users will accept a traditional PBX phone, a desk phone, as a good quality. First of all, it will use a G711, most probable, and in most cases, it's reliable. So every time there is a dial tone, every time you can make a call. However, most of the users will actually trade a voice quality to some additional benefits they can get from a solution. As an example, mobile phone users, they actually traded the reliability to mobility itself, as well as voice over IP, a public voice over IP service users will trade voice quality to the price of the service. So similar to Lync, in most cases, users will expect better quality while they're working from the office, and they will accept less quality while they're traveling and using public internet for remote access. What challenges you can meet and what challenges can come from the network itself? First of all, two types of issues you can expect: the call reliability and audio quality. I will not go very deep into that slide, but you just need to understand there's a good number of devices and applications and services which can give you, which can bring some issues into your service. So it can be dropping calls, it can be delays, it can be echo, whatever. And it may be caused by end-user device, it may be caused by your core call control application, it may be caused by the gateway. So you will need to check all that devices and equipment to troubleshoot potential issue. So this is why a monitoring tool is very important, because it can give you a quick view and quick understanding what is going on within your network, within your solution. So this is like a reference about a network performance goal. This is Microsoft recommended numbers. And you can see that other vendors can recommend different numbers because it is based on the codec they're using in their solution. So these performance goals are based on RT audio, which is quite adaptive codec and can work well on unmanaged networks. You can find details on Microsoft website. It's not only about the network performance. There is a document about what equipment you should use, what equipment is certified, what the CPU goal for front end, et cetera, et cetera. There is a lot of different documentations which can help you to figure out what the performance you are looking for. And now we are going to open systems interconnection model. Is anyone familiar with OCI model? Is there anyone who can tell us the definition of the layers, starting from the bottom? We have a prize. Just one. Someone more. Who? You. Yep. Pardon?
Speak up, please.
Yes. 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 Yep, and application. Well done.
Australia Post suck, they never deliver parcels.
Okay, the voice will use the same model on a network. So how it works? For example, we have our voice sample. Each layer will add its own overhead to our payload, and we'll pass it to the next layer where another header will be added. And it will continue until it hits the physical layer, your wires, etc., and will be transferred to the remote side, where it will go opposite direction. So we actually tried to align the OCI model layers to topics we are going to discuss today. Don't blame us for that alignment. We actually try to do our best. In some cases, there is no logic, but there it is. And we will start with the bandwidth on the physical layer, but it's somehow related, right? Any voice over IP call has two main things. First of all is a signaling, and in our case is a SIP, and a media. In our case is secure RTP accompanied with RTCP information. So how the codec works? It will packetize the voice sample into a number of packets. In a perfect network, that packets will get to the destination successfully and unchanged. So on the other side, the codec will be able to reproduce the audio based on the packets. But what can happen if you have a poor network? Some of them can be lost, right? Or delayed or whatever. So there are mechanisms within the codec itself to prevent that from happening. We've got forward error correction mechanism. Well, basically, it will add the same sample to the next packet to increase the chance that every sample will travel successfully to the other end. So let's imagine that we actually lost 2 packets. But as you can see, on another side, we still have 4 or 5 because of the error correction mechanism. But we do not have the third packet anyway. Again, the codec has another mechanism to restore that lost packet based on some voice algorithms. And most probably you will not notice that loss anyway. So with Lync, the media endpoints itself, media clients itself, are smart enough to provide some sort of priority to audio. And for example, it can prioritize audio and give more bandwidth to audio and then distribute remaining bandwidth to other media like video or web collaboration. Moreover, it can use RTCP to understand the network conditions because it will exchange RTCP information for the remote endpoint and see what actually happened on the network. It can switch codec based on that information. So the endpoints itself smart enough to adapt to a network conditions. Finally, what is defined the bandwidth requirements? First of all, codec choice, because every codec has a different payload size. Network performance, because it may force the codec to switch forward error correction, which will add some bandwidth on top of the codec payload. And finally, the channel activity. If you keep silent, you will transmit less bandwidth. But it's not very useful for audio, but for video, for example, if you're just transmitting a very still picture, the bandwidth will reduce dramatically. If you're dancing in front of a camera, you will send a lot of bandwidth for video, as well as this similar to. Yeah. OK, the question is Lync client always use RT audio by default, or it can choose to use some other codecs, right, at the beginning of the session? First of all, with Lync, by default, it can use RT audio wideband, or can start using G711 if it talks to another Lync client on the same network. Because G711 has less CPU load, so the endpoint will choose to prefer G711 even to talk to another Lync client on the same network. So it will actually check the network condition, and it can start G711. By the way, G722 is used for the conferencing calls only. It never used for media bypass or peer-to-peer calls. Okay?
And just to add to that comment, there is a internal 70-page document which describes the algorithm actually, how two endpoints actually choose whichever is the best option. And if you come tomorrow to Edge session, we'll show you actually how you can start conversation with one codec or one IPs, but like 2 minutes later, you may end up actually having completely different codec, completely different sets of IPs. Come tomorrow to the Edge session. We'll talk about it. Good question. Price.
And now we, yeah.
Is there a way to change that geographical locations?
Yes. So the question is there a way to change that behavior based on the geographic location, right? Yes. And there is a call admission control for that. So you can define your sites, your locations, based on network information, and then you can define policies applied for particular locations, as well as a policy applied for link between these locations. And you can say, OK, for that location, I'm going to use narrowband RT audio codec only, and that's it. No other codecs available, for example. You will limit it by limiting the bandwidth available for a voice session. So we will Yeah, we will cover it in the call admission control section, yeah, just in a couple of minutes. Can you actually do it?
Yeah, all right. You have a rest.
Yeah.
Basically, what we would like to do, as you know, the Microsoft has enhanced stack for the codec. So we can do our codecs. We can sense the network constantly, which means any voice over IP system, when you have voice established, what will happen any other system, they will just generate 50 packets per second, hoping that network will cope with that. If there is a bad things happening within the network, QoS will kick in and voice will go through. We do things a little bit differently. We'll establish a conversation with the codec. We will start sensing constantly the network. That's what's our enhanced media stack. And if we see a lot of jitter or packet loss, we'll change a codec and we'll kick in forward their correction. And we're constantly changing this. We're constantly sensing a network. For video, forward their correction actually inbuilt into the codec itself. So for video, you won't have that sort of switch. I'm losing a packet, I have to do. So that's why video is also a little bit, you're using a little bit more bandwidth. So what we'd like to do, we'd like to show you basically to fire up a video session, and we would like to basically make a network not as pretty as it's usually, and to show you basically the difference, what it can be if you run the video communications across bad networks. So I've got one of our colleagues, Selvan, in the room. What I'll do, I'll fire up the video session, and at the same time, can you see my screen? Yes, great. At the same time, we've got this tool which is called Network Emulator, and we can emulate any conditions. If you have been on Andrew's session, you probably have seen we're all using this tool actually to demo or do some testing. So what I'm going to do, I'm going to emulate normal conditions, and then I'm just going to start injecting the packet losses. And we would like to show you actually what actually happening with the system when you have a lot of packet losses. While doing that, just to probably to test it, I will ping our guys, our friends, because we know they always respond. We just want to keep their servers busy. So that's where it is going, and you can see, oops. So we'll start normal network emulation, and as you can see, there is a traffic going, and if I would like to understand, there is nearly no loss rate. It's a normal network condition. Actually, I might just make it a little bit smaller. So as you can see, it's all working well. And I will at the same time fire up the Selvan session with Selvan, and I will go to video. Now, we are apologizing. Well, at the beginning of the session, we didn't manage to find any microphone around, so we probably won't have a voice, but the most important, we would like to show actually what actually happening with the video itself. Selvan?
He's falling asleep.
Yeah. Are you here? All right, here we go. We've got a Selvan in a session. So we can see it's a normal video. Oops, I'll probably shut this down. It's a normal video, no packet loss. So let's start making this changes to the network, and let's go to the random loss of, I don't know,
20%.
Okay, 20. Let's go to 20. Probably random loss of 20.
So we're going to lose 20% of Selvan today.
On inbound and outbound. Well, let's first of all see, are we really losing anything? Yes, because you can see the ping starts dropping, and but video is still working. I mean, what likely is happening, we started using a little bit more bandwidth. We can see there is a packet loss happening. The forward error correction actually kicked in. Once we notice the loss, it actually starts sending a little bit more packets. But still we're coping with that. Again, the codec dynamically cop. And let's make it a little bit worse. So if we raise these to... You, from the client side, in the end of the call, you can see what was happening with the call through the monitoring server, because that enhanced media stack, when you finish your call, it will generate the CDR records, will save them into the front end, and it will send each client around 4 kilobytes of data from all the quality of service experience. It will tell you the packet loss, the jitter, the mean opinion score, all the information is there.
Including the codec.
Yes. I'm not sure the switching will show. I'm not sure that will show. So let's make it 40%. That's a 40%. Here we go. We're losing a lot. Selvon, can you move a little bit? Yeah, we freezed. So you can understand if someone is really complaining about the fact my video gone bad and I haven't done anything to the network. This is sort of behavior you would expect. Now, if you are sitting in somewhere in McDonald's, and this is a free public internet, you connect it to the public internet on the Lync land, that's what I would expect. I wouldn't expect this to be top quality. Although my 3G actually wireless card sometimes makes better quality than this. But if you are sitting and running in the office with this sort of quality, that's probably something is wrong happening with the network. And this is why we're very heavily recommending deploying a monitoring tool. You can go back. If someone complained, I had a bad quality experience with a specific call, you no longer go and chase the network guys and say, what's happening with your network? And the usual answer is we have to go and put the probes. Well, guess what? The problem's gone. The probe's not going to capture the traffic that are in the past. So having a monitoring server is really crucial so you can go into the specific call, drill down and see, are there any packet losses? Are there any jitters or what's happening in the call? On our showcase, we have got monitoring server actually installed. So please come in, talk to us, and we can actually show you what sort of stats you can get out of the call. All right, so we'll let Selvon go and kick in with the presentation further. No. Oh. Yes.
Is it possible to set some thresholds so that if the tool recognizes the network can't handle it, it won't let you set up the call?
The question is there any way to set a threshold that the Lync client understands on the particular network conditions it will not allow the call, right? No. No, you can actually provision, you can configure what the maximum bandwidth available for a particular call, for the session itself. If you set it into 0, so it will actually deny the call, but there is no dynamics in it. So it cannot recognize, okay, there is very bad network conditions, should I set it into 0? No.
But what you can do, because all these monitoring quality of service records, they are stored in a SQL database. You can write a specific query to go probably once every hour if it's a critical, or once every day, basically to query database and start looking some specific events like packet loss more than 10%, delay more than specific value. So then you can get some information that, hey, those events are happening within my system. I better go actually to have a look.
And even more, you can now create a script, a PowerShell script, which can feed from that information and then dynamically adjust your call admission control system. So, but it's a little bit complicated. It's not available out of box, but I see a couple of workarounds how you can actually deploy it.
Can we take its SCORM management pack offline?
Yeah.
Different sets of conversation. Sorry. Yes, question. No. No, we just only get the stats out of the boxes, out of the endpoints. Yes? Everything. It's basically, it is the quality of service record about the call. It will tell you what it is. It's a CIF, it's a VGA, what type of camera you use, what type of headset you use. Sorry.
I've got a monitoring server here. While Vakhtang is presenting, I will actually show, after the session, during the Q&A session, I will show just a common record from monitoring server.
Is it possible to store the conversations for auditing purposes?
Pardon?
Is it possible to
No. The question is, can we basically record the conversation like voice, right, on monitoring server? No. Monitoring server will keep only information about the conversation, not the conversation itself. There are third-party solutions to make the call records for any particular reason, but no, not out of box. Yeah. Last question, and then we have to go.
Sorry, just an answer to that one. If you need to record a single conversation, you can do it as a meeting, and then you can record the meeting.
Yeah.
So, like a conference call, you can just have two people in the conference, but then you can record that, so you get a result.
Yeah, but it will be recorded on the client side. It's not on the monitoring side, or not on the server side. So yes, you can, in the Lync client, you can make a record of the conference call. Yeah, you can treat the system and you can make a peer-to-peer call, but then add someone to that to be able to record it. But it will be recorded on the client side. Okay? So we move on. This is a bandwidth planning reference information. You can get more details from the Microsoft website. And there is a special bandwidth calculation tool, which is Excel-based tool. And I'm going to show how it's look like. But these numbers might be different from what you probably heard from Microsoft guys and other guys. These numbers is particularly designed to use for call admission control planning. Okay? And there are two numbers you will use: the maximum without error correction and maximum with error correction. Let's do we have an example during the call admission control session?
Yes.
Yeah. So we will
We'll
not
talk about call admission control.
For bandwidth application sharing, it's a little bit different. First of all, you cannot control a bandwidth for application sharing using call admission control subsystem. So it will, you will be able to control audio and video. But that is very interesting because the traffic for application sharing has that spikes. So it may take just a couple of kilobytes of a bandwidth during the whole application sharing. But when you change slides, there might spikes occur. And that spikes definitely depends on the content. If it's just slides, it's not a huge issue. But if it's animated slides, it's a different story. However, within a Lync, within the user policy, there is a way to limit that spikes. So you're not limiting the overall bandwidth for the session or something, but you can limit, based on user groups, you can limit how big that spikes can be. Okay? There are also the policies which can be applied for user groups. So it's different from what we are going to discuss in call admission control section, because it's applied on the user base. But call admission control applies on the network base. Okay? It's different. But you can combine two tools to provide different policies for different users. You can provide one policy for like general staff and some different policies for your executives. So there are PowerShell commands which you can use to set that policies for bandwidth. And now we're going through a demo for planning tool. What is it? It is. So this is. Hey, it's not. It's a different one.
It's on the screen. Go.
Yeah. Wait a minute. Yeah. So this tool is designed to help you to identify when bandwidth is required for a particular end user scenario, and also help you to configure your Lync for your call admission control system. So you will start here and then go through all that steps. It seems quite complicated, but it's not a rocket science. So Then you can define all your sites, all bandwidths, total number of users, what WAN links you've got today, etc., etc. And then it will actually bring you, oops, where is it? No. It will bring you to some sort of results when you can see what bandwidth is required for any particular WAN links between sites and what you've got today. It will take from information you input. And you can use it to predict what voice quality you can get from the existing network, or what WAN links you need to upgrade, or probably you just decided, OK, I'm going to limit the bandwidth, and I will limit the number of calls. I'm going to limit which codec should be used for any particular location. Okay, this is publicly available. You can download it from Microsoft website. And on this, I exceed my bandwidth, and we'll ask Vakhtang to continue.
So basically, there is a document which is called Microsoft Quality of Service. Sorry, Quality of Experience. It's available on the web. Please download it, read it. There's a lot of information which describes actually how the Microsoft stack works, what actually we do, and how things are reported. It's a white paper. It's not a very deep technical, but it gives you some understanding. It gives you understanding how basically the whole thing works together. As of today, so we spoke about the bandwidth. Yes, it's very critical. Depending on the call, as you know, we're not forcing users to certain locations specifically to use specific codecs. Codecs adjusted dynamically, so that's sort of touching. And that's on a wide area network. But what's happening actually on a local area networks? How many of you guys actually running multiple VLANs for voice and for data? Anyone runs common VLAN for voice and data? Great. It depends. What is the right, wrong? There are no right and wrong choices. Which one is a better way? Each of them have its separate advantages and disadvantages. Separating into multiple VLANs is great to do the isolation of the broadcast domains. Well, that's probably most of the times why VLAN has been created. So there are possibilities. So what we found that when you bring the IP phones, just the pure IP phone deployment, in the most of the cases where you have got voice and data VLAN capability, so we are supporting the automatic VLAN discovery and assignment by IP phones. We are supporting, as long as your switches are supporting LLDP MAT, actually you can configure it, plug an IP phone, and then the phone will suddenly appear on the voice VLAN, and the PC running at the back of the IP phone, if they are daisy chained, they will be actually landing on a native VLAN. We call it data VLAN. That's possible. It is supported. What it is happening if you're running an IP phone with a the PC with a Lync client and USB at the back? Well, it is a common, basically, segment. We do not support in Windows capability to tunnel a VLAN traffic within a common VLAN. It just, well, it's not there. It's a science fiction if someone says they can do it. So if you are interested to see the pros and cons of having a multiple VLANs versus one VLAN, please, it's a much longer conversation, more than 25 minutes I have, and see us online or have a chat with us at Showcase. We'll be able to basically explain you what are pros and cons of that. Basically, the quality of service. I suppose most of us I would expect most of us run quality of service on wide area network links. And the reason for that, because our carriers want us to buy more different type of the traffic class, and basically we also do. But as a bigger driver, and can anyone who doesn't run QoS on the links? You must be running the Ethernet links, 100 megs. Yes? No? No QoS? Well, there is a way. No, but Telstra supports QoS. Well, that's what I'm saying. The carriers want us to buy different traffic classes, And then you will have it on the WAN. But having a QoS on the WAN becomes sort of it's a standard. You have to have it. That's sort of people would expect and carriers would expect you to buy. But what people sometimes forget is that your traffic travels across wide area network, hits the router, and comes, guess what, where? Into your LAN. You need to have QoS on the LAN too. You can't just have QoS on the WAN and completely forget about the QoS on the LAN. So you need to run this. And the rule of thumb for QoS is if you have got chain of 5 switches and 7 routers, and if one of them is not configured properly for QoS, guess what? You don't have QoS at all. There is no like a 50% QoS. It's just gone. It disappears. So it's very important for us actually from the Lync side to support all the models you have. I can't believe I still keep hearing the statement that I have a quality of experience with Microsoft, I have a call admission control, and I know only the QoS on the LAN. Well, this is a bold statement. You need to have QoS on the LAN, on the WAN, not on the internet, of course. But you need to have that. And we do not substitute each other. We work together to deliver the best experience for users. So going back to a little bit of a story, I've been on a network side from 2001, and I've seen the different models of QoS. They were the differentiated services model and the resource reservation model. Well, the differentiated services model actually have won the battle. We think so, but if you talk with most of your telco providers and ask them what sort of protocols do they run inside their MPLS clouds, you'll find they still run a lot of RSVP protocols. They use some of this. But anyway, what you are seeing as a customer is a differentiated services model. Basically, the whole model based on a per-hop behavior, basically. Predefined traffic classes that predefined by the telcos, and you usually, as a customer, you define your QoS domain. You define a specific treatment for specific classes. You configure your switches, starting from distribution, starting your access, go to distribution, go to the core, and at each level, actually, you configure different things to happen to your traffic. But everything is based on this 8-bit toss, actually, coming out of your IP header. So diff services code point, if you want to learn, basically, if you don't know what it is, basically go to the internet, read a little bit more. But I think DSCP is such a point that there's a lot of conversations going around it. So from our side, from the Lync side, what we do, number one, for Windows 7 and Vista, well, 7, I would say, from this going onward point, we support policy-based QoS. What is the difference between policy-based QoS rather than just simply setting a registries to mark any packet? Because you can, yes? Give him a prize. Yes, that's right. Basically, you can define which application can generate a traffic. And that's sort of, it is always that sort of security for you that you won't have any rogue applications running on the Windows actually and marking packets and taking some of the precious bandwidth off your local area network and wide area network. Lync phones, actually, they will mark points by default based on the specific settings that you can define within a Lync. And Windows XP and Macs, we basically, one of the approaches we recommend, based on the ports, classify those packets and then treat them accordingly within your network. And this is a very interesting point that, yes, we will classify those. Yes, question?
We understand the marking of packets out there.
Yeah.
What about when they're being received by the server on the client side? Are they all being received into the same classification?
No, this is the point that a lot of integrators miss. You classify packets. I'm speaking here. The packets are classified. They hit the telco router, usually reclassified. Trust me, they are reclassified by telco. They're coming in, and you have to classify them back if you have proper QoS. You can't just say anything else, just go there. There's heaps of bandwidth. No. If you do end-to-end QoS, you have to think about inbound traffic. And inbound, not coming from the guy who speaks, inbound coming from the telco. You need to really understand what do they do with those IP packets? How do they mark? Because remember, most of the times on the LAN, you take a traffic trust on the layer 2, which is your costs. And then you map it back to your layer 3 DSCP. And guess what? When a packet's coming from the router into your network, you make your basically layer 2 header changes. And with layer 2, you're changing your coarse markings. So in case if you miss that point, what's going to happen? All voice over IP packets going to come from the telco, going to hit the router. Router going to say, I don't know anything. I'm building the layer 2 header. Write the cost class of service 0. It's going to hit the switch, voice packet. Switch going to say, oh, class of service 0. This is not voice packet. Going to set DSCP 0. I'm going to go into the data bucket. That's it. You just lost QoS.
Well, I mean, when the packet has successfully made it to the server or the endpoint,
Yes.
and it has been marked with a skill mark, does the server or the application actually categorize or classify that data? Say, hang on, I'm getting a lot of registration requests for log on, but I've also got a lot of voice traffic. Am I going to process voice traffic first? Or am I going to process
No. No, we don't. There is a QoS scheduler. Is that the one you're referring to? Packets, QoS packet scheduler? No, I don't think so. We recommend. No, we don't recommend. We don't recommend even turning that on. That's a give me a price. Good question. So what we will do, cautious of time, we will support classifications the way you want. And we will actually work, there is a recommendation for Microsoft, but usually you will see these recommendations likely will map to all of the QoS mechanisms you do, which are the priority queue for your voice, specific class-based queues for a video and the rest of them. And basically treatment should be the same. The only difference is, as you can see here, for video traffic, there is a recommendation to put basically random early detection. That sometimes bring a little bit of conversation with the data guys, like, you mean you don't randomly detect voice and drop, you want to do video? Well, yes, that's our official line, is that's what actually we recommend to go with. So in not every cases, not every telco in Australia and worldwide support blindly any markings you do on the packets. So what they're going to do, they're going to say, I don't care, and I know some of telcos in Australia do, they don't care how you mark them on layer 2, on layer 3. They will ask you to actually give me the range of the ports, and I'll classify accordingly. Yes, question?
Since Microsoft really compress their traffic using codecs, what additional benefits do hardware compression of the WAN link, what effect does that have?
First of all, there is nothing to compress in the voice packet.
Yeah, but it does store cached.
You cannot do that. Because this is a real, remember, this is a real-time communication. Even a minute late, even milliseconds late actually may change the way things are working and things are received by.
But if you're broadcasting from one site to 2 users at the other side,
Yes.
and the branch repeaters are picking up that, hold on, that traffic, that packet is...
We do not broadcast. We unicast to every separate IP.
We do not use multicast, so.
We do not broadcast at all. Conferences, music on hold, everything is unicast. We don't do any multicasting at all. So it's a little bit different concept. Vendors like Cisco, vendors like 3Com, and one of my friends knows how much fun we had with multicasting. Even sometimes time is delivered via multicast, not with us. No, we don't do multicast at all.
But if it's 64K per channel, could we further compress it using a WAN?
If you understand the IP structure of the packet, the only place you can compress is a UDP, RTP, TCP header. Sorry, IP UDP RTP header. That's the only header, which is 40K going down. You can compress to 2-3K, but even our friends at Cisco wouldn't recommend you to do that. If you take any one vendor, no one would actually recommend. And if you speak with... No, you can't.
No, wait.
You can't. You can't compress a payload.
You're actually using these devices to compress other traffic, not a voice.
If you deploy the WAN optimization technologies, the main line is keep the media content, rich content separate line. Don't compress it. Yeah. The only way they would say we can optimize voice by compressing IP, RTP, UDP header. But again, you don't want to touch that. Yeah.
You still have it.
Yes. Yeah. And that's an interesting point, because once customers start deploying all these QoS technologies, I've seen in my life, sometimes you've got mismatch what's router on the WAN side configured and what's shaper configured. It's like, if you're going to enforce them at 2 points, you're going to make sure they do actually identical jobs. They synchronize together. All right. So what we can do, we can mark the packets. We can specify specific range for the ports for every type of communication for Lync. That can be voice. That can be audio video conferencing, separately voice streams and video streams. And now, the most important, we can apply those ranges for servers and for clients. Question, can you tell me, please, based on what you see here, on the port ranges, 57,480 to 57,500, if that's applied to the user, how many concurrent calls can have a user? Let's say it's a pure voice conversation. Wrong. No. It's a UDP.
21.
No. No. Why? No.
No.
Okay, give me a present. We use only 10 ports, and the
Cool.
reason is because every conversation consumes 2 ports. It's an RTP and RTCP. We use a separate channel to do RTCP, real-time control protocol. This is where the endpoints exchange a network stats. Every vendor in the world supports RTCP protocol, but not every vendor reads the data out of that protocol. Our media stack uses that protocol, reads the data, and make a decision, change a codec, and says, network gone bad, change it. You can change this, and this is the dilemma. If this is a reception, and when they receive the 11th call, what's going to happen? Engage. There is no way to make a call. So be very careful when you're assigning the ports. If you notice assigning enough ports for receptions, they can't just receive a call. If they're very busy reception, 10 calls at the same time. So you can do this sort of marking, and it's possible on end. Now this is the most interesting. How many of you are familiar with the Lync call admission control tech concepts? All right. Can anyone tell me what a call admission control is?
Before you establish a call, you check whether you've got sufficient bandwidth to satisfy that call.
Excellent. Beautiful. Beautiful. Yes, we'll go through that. Yes, we'll go through that, and I'll show you a check. Basically, with the call admission control, what we do, we define my region. We define, it's probably we're running a little bit short of time to tell you very deep. I can speak 4 hours on call admission control. But basically, you define your network, you define your region, you define your sites. Region is a collection of the sites. Sites is a collection of the subnets. And we had previous session, we had a question about, can I go and summarize my routes? Well, yes, but you completely, what's the point of doing call admission control if you're going to start summarizing the routes? That's not. As much as deep you can go, basically you take your network topology and build that network topology inside Lync in the form of having a site, having a subnet actually at certain sites belonging. And then you deploy specific limits per session, audio and video, and per total for that site. You can say for this site, I don't want to receive more than, or I don't want to make more than a certain amount of the bandwidth calls. So what will happen? When I'm trying to make a call and there is not enough bandwidth, I will be rejected. If I'm trying to make a call and there is enough available bandwidth, you will make a call. So that's the principle we use, those bandwidth values, because what Lync can do, G711, it can do RT audio, RT video, we can do forward error correction, and we can do G722 for conferencing, heaps of codecs. But if the call admission control is enabled on a site, Lync, when 2 points are negotiating, they only will have limited set of codecs to choose from based on how much actually available for the site. So as you can see on this example, let's say I've got a Melbourne and Sydney, and I'm limiting, where is my laser? Oh, I'm limiting that audio session should have maximum of 60K per session. Once I set that limit, that means only certain codecs I can choose. If it's a 60K, I can do only narrowband with forward error correction, narrowband without, of course, because it uses less bandwidth, siren for conferencing an RT audio wideband codec. Now, how the call admission control will work? When the user A, any user, call user B, the called party requests a service and says, can I make a call? And then, based on the different conditions and checks which I will show you, then the call is actually either allowed or not. Now, can anyone tell me why edge is important in this case? Yes? Yes and no. It is an option, yes. It's right to say call admission control gives you capability. If you don't have enough bandwidth, if everyone goes down via PSTN, well, it's going to be a lot of money spent. We don't want to do that. But what actually is happening, we can go and see if there is an alternate path through the internet from the site available. We can come back from edge, but that's not only the case. Yes?
So we got the limited bandwidth, so we got the data and more together, so you have to, like you said, bandwidth for voice and bandwidth for data.
No.
In your network.
Now, if you come tomorrow to the session of the edge, we'll cover it. Basically, edge, all these negotiations, clients, basically when two Lync clients negotiate to each other, is a bit of chit-chat going between them. Because they have to realize who has a band, what sort of IP addresses can talk together. There's ICE and STAN and turn all these protocols. And actually, edge is, unfortunately, but that's what the design is, edge is the main enforcement policy. So the rule of thumb is, if you have edge in a topology, and if you have call admission control, you better make sure edge is fully redundant. Because if edge is not available, you don't have call admission control. You just simply turn it off. You can enable call admission control within a network, but if edge is not reachable by the clients, they can do anything they want. That's what it is. I'm not commenting why, what's the reason. What I'm saying, be careful if you blow the edge and call admission control. Make sure it is reliable. So what will happen? Let's say if someone want to dial in user A to user B. It can go over the internet. It can be some other site where actually you're enforcing a bandwidth. So you can see the RT audio wide bandwidth actually with no FAC will be established because I can do it. It still fits 60K. But what will happen if there is a congestion on the internet? The same congestion can actually happen on inside wide area network. What will happen then? The client will say, well, there is a packet loss, or can be delay, something else. I have to enforce forward error correction. Then it goes back and says, because of the limit of 60K, what options do I have to enforce forward error correction? And because you have only one option to narrowband, so you see what's happening mid-call, we changed the codec type. We've gone from wideband to narrowband. So we changed a little bit of quality of the call of the sound, but we're compromising that to the call, to the fact is users still will receive consistent actually speech coming from the other user. So that's actually how the call admission control works. And just one comment about a couple of sessions has been, we do not recommend to do media bypass across wide area networks when you have a call admission control. Reason for that, call admission control and media bypass don't work together. You either can have media bypass or call admission control. That's why we recommend when you do your designs, make sure the media bypass actually stays on the local side. That's where actually it was designed to stay, not coming across wide area network. CAC demo, just to show you very quickly, guys, what it is and actually what you need to look at. Basically, you take the basically you take a traces on a front-end server, although you have an edge and everything is enforced through the edge, but you take traces from the front-end server. And I, for example, here we go. I took a trace of, this was in my lab, of basically successful call. Here we go. So as you can see, this is bandwidth check request. Basically, IP1, which is .91, trying to call the .91. I think .91 was calling .90, and basically the request was we always request minimum 40K and maximum of 200K per session. That's the request gone, and that's after that. Once request gone, because call admission control enables calls on a network. Actually, the server actually checked both of the sides. You can see this is a head office side. It checked the bandwidth and says, yes, you are allowed to do, because it's actually allocated 100K per call. And here we go. You can see your limits are 1,000 for audio, video, and concurrently there is no usage in that. And at the same time, oops, where am I? At the same time, it's gone another check, cross-check against the branch. Now, if the branch would be completely saturated, call will fail. That's basically the main thing. It checks both locations. I've been asked a lot of times the question, what's the difference between your call admission control and Cisco's call admission control? The fact is, the main difference is, well, we allow calls to go through, we stop calls going through, but the main difference, we understand network topology. You can establish that the left part will have their rules, and the right path will have their rules. Like some of the Telstra still have Queensland and network in Queensland, network in Victoria, and sometimes, although they give you a lot of bandwidth, but sometimes they limit bandwidth between regions. So what we can do, we can say the traffic from this end can go to traffic to that far end, passing through the region. So when you pass through the region, you can say in our call admission control that when you pass through the region, apparently you have to hop on and hop off through the certain sites which have bandwidth enforcement policies. So if this was the case of user A calling user B and they have to go through the region which has a bandwidth limitations, we will check every point, every enforcement. If any of the points failed, we actually will reject call or reroute calls actually across.
Yep. Just one comment on it.
Yep.
Actually, in Lync, the B point, for example, user A calling user B, and the B point, the remote point, will ask for the call admission control request. So not the initiator of the call, but who is answering the call. Because you can be logged in many devices, and the call will be forked. Depends on which device you're using to answer. That device will make a request to call admission control if that device allowed to take that call. Okay? It's not A side, it's a B side who is asking for call admission control.
Yeah. Resiliency. Yep.
If the edge server is down,
Yes.
call admission control can't be checked.
Off.
No, it's off. No, it will allow any calls by
Any
default.
calls, any to any.
Your WAN link goes down, I can't talk to the edge server.
Yeah, you will be able to make any calls
If
anywhere.
your WAN link is down, if you
You
don't have
local.
SBA, you're going to be down. If you have SBA, you'll be able to just make PSTN and receive. As long as what we're saying, if you have all the network operational, you have got one edge server, it's crashed, your call admission control crashed. Gone, out of the window. So that's why important to have redundancy in the edge. Come tomorrow to morning session, and it's after party, but come guys tomorrow to session. We're going to be speaking about the edge and how these things are working. Now, big difference in resiliency. I'm meant to do the demo. I probably won't do it. With OCS, we suffered in the fact that if I lose suddenly connectivity in the network, actually I immediately lose any type of. If I lose connectivity to front-end server, I lose actually my media going. Let's say if I'm speaking with Victor on the network and suddenly we lose by some way, not when, but suddenly something happened with the front-end server, our conversations would stop. We actually changed that, not fixed, changed, sorry. So what will happen with session resiliency if we are speaking together and in case if we lose a connection to the front-end server, our media between us, two endpoints still will go. And if we have a gateway and connection to PSTN, that's called survivability basically. Our media will still fly. That will work, and that's a big change with us. And that proves to the fact that sometimes you have a glitches in a network. So because it's a glitches of the network, it's more give you capability actually to continue a conversation. And of course, because in the client now we're caching all the credentials, we're caching all the front-end addresses, it is much faster sign-in process for that. Do we have time for this?
3 minutes.
3 minutes. No. Actually, I'll do this session and we'll probably will go to questions. Are you ready? No? Right. All right. We'll
Then-
move on.
Yeah.
2 minutes. Look, come and have a chat with us. We are on the stand. We're happy to show you guys how this works. And partners, definitely, because if you've been attending today's morning session, you've seen we have got the whole stack of basically all USCMA, all the interfaces there. Basically, you can develop applications. But in addition to the applications, when you deploy Lync, you come across things like load balancers. We've introduced the concept of a DNS load balancing, but it doesn't mean it's a replacement of hardware load balancers. You still need to use the hardware load balancers. So we have a range of the partners actually who work on a load balancing area, who provide us good solutions for us. I think in Australia, most of the times we're coming across, where are they?
F5.
F5. Oh, here we go, yes. F5, and we've seen a number of times guys from trying to deploy the hardware load balancers on the Cisco blades for 6000 series. Yes?
Sorry. Apologies if it's a bit of a newbie sort of question, but it's one I've been wanting to ask for a while. Now that Microsoft's acquired Skype, there's a lot of talk about the resource kit book telling us how to integrate Skype SIP connectivity into Lync, and apparently this resource kit book is meant to drive hints at that. Is there any direction, or is this ever going to happen? Is Microsoft
It is.
going to
It is. The guidance is, it's not, sorry.
Skype SIP into Lync, and the resource kit book drops hints apparently at how to do it, and I can't find out how to do it.
The question is what's going to happen actually between us and Skype, and will we have direct integration, SIP trunking? Well, the question is, first of all, official line is we haven't completed the acquisition of the Skype yet. It's still pending regulatory. Here we go. We got it. So I'm glad I have you. So it's once we have more information, actually, we'll be able to share it. But I'm sure I've seen some guides on the network actually using a third-party devices. You actually can integrate this. Yeah. There is a possibility, but is it a direct official line for Microsoft? Not yet. Wait.
Any hints on time frame?
Oh no! I think we need to buy them first of all. You know, it's not officially. Yeah, it's state regulations. They have to give their approval. So we're waiting. Yeah, there we go. So the way you can interact, basically, Victor covered very well in the session before. You can go direct SIP. Between PIBXs, we can bring a direct SIP. Right now, on the showcase, we have MyNet phone trunk coming over the internet straight into the Lync server. We don't have gateway, for example, in this case. And MyNet phone is certified as a SIP trunk provider for Microsoft Lync. It is working. You can come and have a look and see how things are configured actually, how it works. Yeah, here we go. So basically, once you're touching a network, it's going to change. That's the main basically message we would like to tell you guys. Before you put this thing on the network, talk to us and make sure you've assessed it properly. Make sure you completely understand what is going to be the impact. And if you're really feeling a little bit not happy in the fact that you can't control what the impact would be, we've got a bunch of partners actually who specializes specifically doing a network assessments and trying to give you the clearer picture. Once you land the link on your network, what's going to happen with that? Questions?
Are there any managed APIs so that I can integrate with the discussion from another, say, website? Just the instant messaging part of it?
Repeat the question.
So I have a in an enterprise network,
Yep.
already set up.
Yep.
And I have a website which provides chatting facility.
Yep.
But I want them to take that chat and put into the Lync network.
Yep.
So
Yep.
that they can carry that on. Are there provisions for that?
Yeah, so the question is, for example, customer has a web portal, and there is a web chat on it deployed. And they deploying Lync internally. is there any way to use that chat to communicate directly to the Lync environment, right? Yes, there is an API available to actually embed anything, any sort of communication options of Lync into your web portal. And go to TechNet
Come
site.
to one of our guys, Selman. He has a lot of information about it. Have a chat with him.
There is a specific website all about the development around Lync.
Thank you very much for